Hello, statistics students. It's me, Gary. We're going to do lab 2 today. I'm going to share my screen with you. So you can access the lab materials either from My Open Math, Math 243, there's a stats lab section. And I'll be posting these a week at a time. I rewrite them each term. So there is a new lab 2. It's a little different than what you might have seen if you looked earlier in the week. If you do the earlier one, that's okay too. That has stuff from week 3, which is kind of a preview. So there's an old video here. This is now the new video I'm making. You can also access it from the Canvas course. So here's the Canvas course, Math 298, and a link to the new lab 2. So let's take a peek. So in this lab, we're going to work on the same stuff we're working on in week 2, sections 2.2 through 2.4. And we're going to look at graphical displays of data, namely histograms and box plots in particular. And we're going to play around with measures of location, quartiles and percentiles. And you definitely need to use a spreadsheet this time. So whether you use Excel or Google Sheets is up to you. This video, I'm going to do Google Sheets. If you have any questions about similar things in Excel, just let me know. So first thing I want to do is read through the things I'm expected to do. So please do that. And once you read through the things you're expected to do, start doing them. And so if you are in this Google Doc here, you can click on the Google Sheet link, and then you have to click again, and that brings you to the data set. So this data set I collected over a couple of years, wandering around malls and soccer fields, asking people if I could take their temperature. So it's not exactly random. There's a little bit of randomness to it, but it is what it is. So I have 520 numbers in this list. We're going to double check that in just a moment. So to proceed, if you're not logged into a Google account right now when reviewing this spreadsheet, all of these items here will be grayed out. And the only thing you'll be able to do is download or print it. If you want to use this in Google, you'll have to log into your Google account and then make a copy. If you're not a Google user, then you could download as an Excel file and work in Excel. Right? So I would here choose make a copy, and then you should choose a better name and maybe file it in a decent folder to work with. So maybe I could call this, your name lab 2. And then you could put it in a different folder in your drive. So decide where you're going to file it away. Make it in the folder right now, just for fun. And put it in there. You can always move the location later. All right, so next thing I would want to do here is double check the count. So I've done the first part of the lab where I've grabbed a copy of this and I've chosen to put it in Google. I'm going to use the count function to double check how many individuals I have in there. So let's go to this one. And here was the original view-only version. I don't need that anymore, so I'm going to close it. And so off to the side here, I'm going to label count. And next to it, I'm going to actually go equals count. And there's a bunch of different kinds of count functions. I'm just going to choose the regular one. And then a couple of ways to do this. You could point to the column heading, click, and say count everything in that column. That sometimes can be a problem. The count function only counts numbers. So if there are any words in here, like a header title at the top, it would ignore that. So count says there's 520. I could also use the count command by clicking on the first number and then Control-Shift down arrow will look for the end of the list. Close your parentheses, hit enter, and it says, yeah, either way, there's 520 numbers in the regions you looked at. So it's a good thing to know that. Let's see, what else do we need to do? So we're going to construct at least 2 histograms with at least 5 intervals with a spreadsheet. Frequency tables are optional here. So we played around with frequency tables quite a bit last week and a little bit this week. I'm going to do it with and without a frequency table here. And Excel can do a similar thing. And Excel, I think, does a better job right now than Google. They go back and forth fighting for better features. So every month or so, you might find a slightly different feature in Google or Excel to do different kinds of things. So with Google, one quick way to make a histogram would be to highlight the data. So I'm going to click on that top number, Control Shift down arrow. If you're a Mac user, it would be Command Shift down arrow. And then somewhere over here in Google, there's a button to insert a chart. You could also go to the Insert menu and choose Chart. They do the same thing. And Google will guess at a chart, and here it guessed correctly histogram. Now sometimes it won't. Sometimes it'll guess at something different, like a line chart. You can just go over here to Chart Type, and then if it's not suggested, you can scroll through looking for it. So a column chart is a histogram, but not. So when you highlight raw data, you have to have a histogram feature. Otherwise, you have to have a frequency table already made. So I'll mention that in just a moment. So here I see there's an option, Other Histogram. So I select it. And then Google guesses at some boundaries for my classes. Classes are also called bins or buckets. Now it did some weird stuff with the numbers on the edge here. I can clean that up. And sometimes it doesn't matter what program you're using, you often have to clean up what the computer tries to guess at. So then I switch from Setup to Customize in the editor. I'm going to go to Histogram, and I'm going to, instead of having it automatically choose the bucket size, bucket is a bin, I'm going to say make it 1 wide. And I have 1, 2, 3, 4, 5. It looks like Google's giving me the finger. I don't think I like that one. So this chart editor with histogram option gives me a way to play around. So maybe I could try 0.5. Enter, and here's the 0.5 version. Oh, that's not too bad. I don't mind that. I could try 0.7. All right, that's okay too. I think I'm going to go back to 0.5. All right, and I'm going to actually create a couple of these. The other thing is I don't like that it started way over here and ends way out here, so I'm going to go to the horizontal axis options, and I'm going to select a new min. I think I will start at looking at that axis. Maybe 96 would be a good place to start, degrees Fahrenheit, and it looks like my data does not go past 101. So just have a little room on the left and the right. I'm going to guess. And you got to play around. So if you guess at a min and the max and you don't like what you selected, try again. And keep playing around until you get something you like. Now 0 for a min would not be good. I have all this crazy blank space. So that's 96 looks pretty good. So if I try 100, that's a little tight on the right. I'm going to go with 101. Yeah, that's more aesthetically pleasing to me. All right, so notice it dropped this histogram way at the bottom. Click off of it, click on it, and then drag it up to where you want it to go. And Google does not make this easy. All right, so the other thing I can do is click on it, Control X to cut, and then scroll up to the top. Oops, come on, up to the top, please. There we go. And stick it over here, Control V to paste. All right, so there's one histogram. And then to make another, I could do the same thing. I could go and highlight the data. I could try doing the whole column. Sometimes that doesn't go well. About as good as before. And maybe you like the automatic way. Now it picks some weird starting and ending numbers, so I don't like that. So let's go to Customize again, and we'll go to the horizontal, and let's start at 96, go up to 101 again, and let's pick a slightly different. Are they jumping by there? Looks like they're jumping by about 0.25, 0.23, somewhere in there. So let's see, we want, so horizontal axis is where I adjust the start and the stop. Histogram is where I change the bucket size. And I wouldn't want to choose a bucket size of 2, right? That's not going to look so good. I want a fractional number. Right? Remember I tried 1 earlier. That looked like it was giving me the finger. 1, 2, 3, 4, 5 categories. You know, it's not too bad. That could be another one. Let's try that. All right, so you can keep playing around with making different histograms. The other way to do it is to make a frequency table. So I could set up a frequency table here. And I would have to come up with some bins. And to do that, I kind of need to know what the min and the max is. So back up to the top here, a couple ways to do that. I could highlight all the data, Control Shift down arrow, and then I could format, data, sort range, doesn't have a header row, A to Z. And then I could scroll through the list and see the maximum is 100 and the minimum is 96.5. So maybe let's start at 96.5 and jump by 0.5. So the next be 0.97. And for a frequency table, a pattern of 2 is good. And remember, these numbers here are the computer bins. That's the maximum acceptable number for each group. So I highlight the 2 of them, let go, grab the bottom corner and fill down to I at least get to the max. There we go. And then I can make a frequency column. And this part is optional. You could use the quick histogram builder. You don't have to make a frequency table. I'm just reviewing this for fun. Then I want to highlight cells to the side, +1, and start typing equals frequency. Hopefully you got this sequence down from last week and the beginning of this week. And I have to go back and highlight the data. So get to the top number, Control Shift down arrow for all of them, comma, comma, and then you have to go find your bins. Way up here somewhere. Scroll, scroll, scroll. That's exciting. Come on, there you are. And then highlight your bins. If you're an Excel user, after you close your parentheses, you do Control Shift Enter. For you Google users, just hit Enter. And here are my numbers. Now, if I want to turn this into a histogram, I would have to highlight both columns, and I want to make a bar chart. Okay, it's a different order of operations than before. And so Google guessed I want a column chart. Now I use column and bar synonymously. For computer, column is vertical, bar is horizontal. And so here's what it looks like. And if my mom or my wife looks at this, she's like, oh, that's interesting. A whole bunch of people had exactly a temperature of 99 or 98.5, and nobody had a temperature of 98.7, 98.6. So these labels at the bottom are misleading. So the problem with this method, to move this over here next to the frequency table, is that at the bottom here, those are misleading. So what I'd like to do is insert a column in between here. So insert column left, and then I would have to do some human readable ones. Now I like the look of this, I'm gonna go for that. So let's call them buckets this time just for fun. And my buckets have a max of 96.5 there, a max of 97. Now 96.5 is covered in this first group. So after that, 96.6 is where the computer would start next, and it would go up to 97. The next category would go from 97.1, right, just after the previous one, up to 97.5. So usually I calculate these guys, and then I go back and say, okay, if that's 97.1, then this must be 96.1 up to 96.5. So the human readable bins, I don't do those until after I've looked at the column chart based on the frequencies to decide if I like the look of it, because these are a pain in the ass to type. And if you have more rows, right, it's even more of a pain. So now that I like that, I'm going to finish typing them. So where do I pick up? 97.6 to 98, 98.1 up to 98.5, 98.6 up to 99, almost done, 99.1 up to 5, and 99.6 up to 100. And you may be wondering why I'm only showing one decimal point. And the reason is my data has one decimal point in it. So I can pinpoint particular numbers based on that. If my data had 2 decimal points, then I would have 2 decimal points in each of these ranges. So let's see, enter. And oh, that's interesting. Google decided to put those as labels here, which I don't know if I like that. That's interesting. I don't remember doing that before. Interesting thing about Google, they change things more often than Microsoft, for example. Unless you use Office 365, that probably changes just as much, the online version of Office. Yeah, I don't like that. So I'm gonna just delete this and rebuild it. So to delete it, I click on it and then hit delete on the keyboard. And this time I'm gonna highlight my new column of frequency and make a chart. So again, making the frequency table is completely optional. You could just use the quick histogram builder. And so now those are labeled at the bottom. And when I point to each of these, it tells me what the count of the column is, which is kind of nice. I just need better labels. So to do that, I go to customize. Let's see what I want to do. Customize titles, and I need a better title than frequency versus buckets. That kind of sucks. So these are 520 human body temperatures. And then the horizontal axis is buckets, that's kind of lame. Temp in Fahrenheit. Can I spell Fahrenheit today? Something like that. Nope. Probably capital F. Nope. Oh, missing the N. Yeah, I got it today. Maybe a little help from the spell checker. Vertical axis, frequency, yeah, that's cool. Sometimes I call it count. All right, so that looks better. My mom would be able to interpret that pretty good. All right, I like that one. Back over here, let's see, I like this one right here, that first one I made, and it's got a shitty title and no labels on the axes, so I definitely need to edit that one. So edit charts, customize titles, and give it a better title. 20 human body temps. And well, that's the vertical axis. Oops, that's not what I do. It's called count. Chart title. There we go. That should be 520 human body temps. And horizontal temp and height. Okay. Looks good. Yeah, I'm not going to worry about labeling this other one here. I have a couple well-labeled graphs. All right, cool. Moving on. So next I want you to sketch your favorite histogram using a ruler and paper. So once you've made a few in your spreadsheet, so I made a few different ones, decide which one you want to draw. So I'm going to draw this one right here. And I already started doing that. Let's see, where did I put that? Over here. That should be this picture. So here's my hand-drawn version of it. So I just got out our ruler and started scaling. So when you draw these by hand, make sure that your marks are equally spaced. So a ruler is quite helpful for making those straight lines. You can see sometimes I freehanded the lines and sometimes I used a ruler. That's reasonably well drawn. I didn't put a title at the top because I thought the horizontal axis label was sufficient. And I have a note that this is count. You could call it frequency if you want. But each axis should be labeled. And you don't have to label every single mark, but label enough so that someone can come and look at this and get an idea of what they're looking at. That's 97, that's 98. What's right in the middle? 97.5. And I just decided a nice scale here. And then just to be clear, I put the count of each column in there. And Google tells you that when you point, there we go, to each of these columns. So first you have to click on it and then point to them. And it will tell you the range and the count. Cool. All right, moving along. Scaled and labeled. All right, and complete sentences describe the shape of the histogram. Oh, interesting. Okay, so let me see. What does that look like to me? Well, it's got a bunch of body temperatures in the middle, around 98 to 99 is where most people seem to be. And then there's a few people that are a little bit lower and a little bit higher than that. And they both pretty much give me the same picture. Most people are around the majority, right? That big stack, 98 to 99. And then there's a few people that are lower, a few people that have a higher temperature. So use your best words to describe what you see in this picture in terms of how the data is distributed, right? The bulk of the data here is between 97.5-ish and 99. And then there's a few people with lower and higher temperatures than that. All right, so you do your best using English to describe what you see in terms of how the data is distributed, the shape of the histogram. All right, write that down, or you can type it into Canvas. Next, we want to do some calculations. Determine the following values: min, quartile 1, median, quartile 3, and the max. Let's do it. So I need a place to work. Let's see. I think I could do that here under count. So I want the min. I want Q1, quartile 1, the median, which often we just call M for median. And let's I want Q3. These numbers are called the 5-number summary and the max. To do that, there's a few ways to do it. One, if I start typing min, Google says, hey, there's a thing called min, a function called find the minimum value of a numeric data set. Hey, that's what I want. So I select it and then highlight my data. Control-Shift down arrow, close parentheses, enter. Q1, start equals, start typing quartile. And I'm just going to use the plain old quartile function. Select it, highlight your data. Make sure you start at the first one and get all of it. You could just grab the whole column in this case because there's nothing else in the column. Always be cautious about that. When you click on the column top, can I really highlight the whole column? Is there other stuff in here that's going to interfere? And then I want, so it's quartile command says, what's your data? And then what quartile do you want? I want quartile 1. Turns out there's 5 different quartiles, so I'll explain that shortly. Median equals MED. Hey, there's median. Grab your data. Q3 equals, start typing quartile. Select quartile, highlight your data, comma, 3 for quartile 3. And the max equals max. Highlight your data, close parentheses. Now, the 5 quartiles, min is quartile 0, meaning 0% of the data is below that number. The max is quartile 4. 4 quarters is 100%, so 100% of the data is at or below the max. The median would be quartile 2. 2 quarters is 50%. So a couple other ways I can get the median, just for fun here. I could say, give me quartile, get the data, 2. Quartile 2 is the median. Now, 2 quarters is 50%, so I could also ask for the 50th percentile. So equals percentile, grab the data, and then the percentile command wants a decimal version of the percent, which would be 0.5 for 50%. And notice all 3 of those numbers are the same. I just want to use median, which is the same thing as quartile 2. Right? See the 2 up there? Which is the same thing as the 50th percentile. We'll do more with percentiles in a minute. So similarly, the max I could also get by using the quartile function. And I don't want quartile 2, I want the 4th quartile, the end of the data. 4 quarters, 100%. Now I'll give you the max, or I could grab the 100th percentile. Percentile command, grab the data, comma, 1 for 100%. Okay. All right, so we'll do more with percentiles in a minute. So once I have these numbers right here, I want to use them to draw a box plot. And so to draw a box plot, you have to have a horizontal axis that has a number line underneath it. Well, one cool thing is I have a number line sitting right here. So the next thing I did with my hand-drawn sketch, hand-drawn sketch over here, is I drew a number line above this using this scale down there. And I put in, that's one version, I'll show you this one right here, yeah. So I just made a mark, right here is 96.5, the min, and then my Q1 was, I think, 98.3. Exactly 98. 98.35, there we go. That picture go. So there's 98, trying to line up over here, best I could, a little off. This is 98.3, that would be 98.5. This would be, what, 90, it's just a little less than 99, what was that? 98.8, and then 100. So I just made a mark where each of those go. 5 marks, draw a box around Q1 and Q3, draw a line through the box at the median, draw whiskers from the edge of the box out to the min, and from the edge of the box up to the max. All right, so next thing I want to do is I want to calculate the interquartile range and then the upper and lower fence. So let's take a look at that. A little space here. Let's make a little space there too. All right, so IQR is just equals Q3 minus Q1. So that's telling me the 0.8, the width of this box from here all the way to there, right, is 0.8 wide, 0.8 degrees Fahrenheit. Okay, back here, and then I want to calculate the upper and lower fence. So to do that, what we do is we take this width here of the interquartile range, the box width, and we multiply it by 1.5, which means make it 50% wider. So maybe that's about this wide. Then we take that new distance and we add it to Q3, and we take that new wider distance and take it away from Q1. That's going to put me somewhere over here and somewhere over here. Okay, let's calculate. So this is called the low fence, and this is called the high fence or upper fence. All right, so the low fence equals, to do a calculation, is Q1 minus 1.5 times the IQR. And that puts me at 98.6. So the next thing I want to do is on my graph, I want to make a mark at 98.6 to show the low fence. And I usually use an asterisk for that. There's different techniques. So if I go back to my picture, I did another one here. So here's my mark at 96.6. And then the other one ends up being right over here. Let's calculate that. Oh, sorry, 96.8. Blow this up a little. Equals. So here I want to go from Q3 and I want to add 1.5 times the interquartile range. Hey, that puts me exactly at the max. That's interesting. Cool. So if I look back at my picture, I want to make an asterisk right in that spot. So if what this tells me is that based on the current data I have, I should expect most people to have a body temperature somewhere between, a normal healthy person, somewhere between, assuming these were normal healthy people, 96.8 and 100 degrees. If a person has a temperature outside of that range, we would consider that unusual, and they are outliers. So notice here that the min is below that lower fence. So that means some of my people had unusually low body temperatures compared to the other people in the sample. So let's look back at that. So 96.8 was my cutoff. So here's 96.8. So those guys are okay, but people before that are unusual. And so it looks like the only numbers I have are a whole bunch of people were 96.5. So just for fun, I'll highlight those guys. And let's see, they're cool. So let's make them light blue. Ooh, that's pretty cool. So these guys right here are my outliers. So I would want to make a note in here, there are potential outliers. And so you could type this up in the submit box in Canvas that, hey, the people that were under 96.8, turns out there were a bunch of people, 9 of them, I think. Yep, 9 of them who had temperatures of 96.5. They're unusually low for a body temperature compared to the other 511 people in the sample. But there are no people that have unusually high temperatures here because the upper fence, the high fence, is the same as the max. So nobody is beyond that to the right. All right, so we are analyzing the data. So let's see, where am I here? I've made these calculations. I've constructed my box plot by drawing it above or below my histogram, and I use the same scale so that they line up. Then identify those on the box plot with an asterisk. With and asterisk? Come on. There we go. Next thing, I want to use the modified box plier. Oh yeah, just so make a note. If there's a min or a max above or below those fences, then there are outliers. So that's what I'm asking about here. What does the IQR represent in this problem? Ooh, good question. So let's see. The IQR is the distance from Q1 to Q3. Well, let's see. That's the end of the first quarter and the beginning of the third quarter. In between there, there's 2 quarters or 50%. So if I look at my picture here, 50% of the people in my sample have a body temperature between what were those numbers again? 98 and 98.8. So 50% of the people are within 0.8 degrees Fahrenheit of each other. So right about that for that question right there. 50% are in that box. What is that box? Well, that box is the distance from 98 to 98.9. So use your best language skills to discuss that. All right, we're getting near the end. What does the shape of the box imply about the concentration of data? Ooh, that's a good question, Gary. Oops, stop, get out of there. All right, so let me see here. Notice that this is min, right? And that's Q1. So the numbers from here to here represent 25%, the first 25% of the people in my sample. And then this range over here is the next 25% of people in my sample. And then this range over here is the next 25% of my people. And here's the last quarter of people. So there's a difference between a quarter and a quartile. So a quarter is 25% of the data. A quartile is an endpoint marking where the quarter ends or begins. So Q1 marks the end of the first quarter and the beginning of the second quarter. Q2, the median, marks the end of the second quarter and the beginning of the third quarter. Q3 marks the end of the third quarter of data and the beginning of the fourth quarter of data. Now notice that the first quarter is rather wide. Okay, so there's a big spread in the first 25% of temperatures in my sample. And then that next quarter is rather tight. Next quarter is not quite as tight, but tight. And the fourth quarter is pretty wide, but not quite as wide as the first quarter. Okay, so the box plot tells me about the concentration of data. If you have a wide quarter, that means the data is very spread out. If you have a narrow quarter, that means the data is very tightly packed together. So we're trying to get an idea of the distribution. Whenever you have a very narrow quarter, you're going to see tall stacks in the box plot, right? Notice the tallest stack is right under that narrow second quarter. And the next 2 tallest stacks are right under the next narrowest quarter. And the shorter stacks are underneath the longer quarters. So there's always going to be that relationship. So this would be like, think of a city. We have a high-rise building here to accommodate all these people. Right, let's see, there's 520 people, half of that's 260, half of that's 130. So there's 130 people crammed into this little box, this little region of the town. That means they need a tall building to live in. And then here, we're out on the edge of the town right here. And so that's where people have bigger yards, more space to move around. There's 130 people that have to live in this space right here. 130 people have to live in this space, and 130 people have to live in this space. So there's a correspondence between the height of a stack and the width of a box in a box plot. All right, almost done. A couple percentile calculations and I'm out of here. So I wanted you to calculate the 2nd percentile, the 16th percentile, and the 84th percentile, and the 98th percentile. And then I asked what percent of the data lies in between there. So I'm going to do P2 and P98. I'll leave you to do P16 and 84 so I can help answer question 14. So I'll make a note here. I want to calculate P2. So that means percentile. So I type equals and start typing percent. I can't spell percent today. And I just want to use the regular old percentile function. And so then I highlight my data, comma, and the decimal version of the percent I want. So 2% would be 0.02, 200ths. Computer says 96.8 marks the 2nd percentile. So that 2% of the data is at or below one of those 96.8s, probably the lower one. Let's do P98. So that's percentile. And then highlight the data. And then 0.98 would be 98%. That's a decimal. So one thing we have to be good at is in this class is converting from percents to decimals and decimals to percents, and then interpreting those. All right, so 99.8 marks the upper one. So if I want to look at how many numbers were between 96.8 and 99.8, I'll include those numbers in there. So let's take a look. So I'm going to highlight them. 99.8, 99.678. Oop, too far. All right. Oop, 99. Ooh, what was it? 99.8? Far enough. There we go. All right. So when you highlight numbers like that, Excel or Google will give a little summary down here, and you can change it. I don't want to add them up. I want to count them. It says there's 505 numbers in between there. I have 520 total. So now technically, if you think about it, if the 2nd percentile marks where there's 2% below, the 98th percentile marks where there's 98% below, then in between 98 minus 2, shouldn't that be 96% of the data lives in between there? So theoretically, that's what I should find. In between 98% and 92%, I should find 96%, because 98 minus 2 is 96. I'm just going to double check that. So I'm going to make a note, percent between, and then equals, oh shit, I forgot, 505, is that what it was? It was 505 divided by the total, 520, about 97. Now, finding percentiles is a little tricky because here it says 96.8 is the 2nd percentile. Well, which one is it? Is it this one? Is it that one? Is it this one? Is it that one? There are techniques to try to better identify which of these people is the right one that marks the 2nd percentile, but I'm not going to worry about it here. We're close enough. So about 97% lives in between. So you're going to try to do the same thing for P16 and P84. And you're going to look to see how many numbers are in between those two temperatures, whatever they end up being, and then find the percent between. So give it your best shot here. And if you have any questions, get in touch with me. We can do a video chat, or I can just try and answer your question through email. Have a good day. Do good math. No, I don't use Zoom much. What happened there? Zoom. Where are you? Computer's thinking about doing something. Oh. Hello? Hello? Oh, here I am. Exit full screen. Oh, I'm not good at using Zoom apparently. Hey, there I am again. And see you later.